Hi everyone, let's work on the review for test 2. First question is asking us to find the domain of a function. This is a rational function. To find the domain, you need to know what are the values that make the denominator 0 and exclude them from your denominator. So I'm going to make the denominator equal to 0 and solve for x. As you know, this is a perfect square, x times x, and this one, 25, is also a perfect square. So this is basically difference between the squares. I have an identity that explains how to factor difference between the squares, and that's this one. A squared minus b squared is a minus b times a plus b. So based on that identity, I can factor this, so I can easily find the zeros of this polynomial. X minus 5, x plus 5. This is how I factor x squared minus 25. Now that I have my polynomial in factored form, I can set each factor equal to 0 and solve for x. X minus 5 equal to 0, so x equal to 5, x plus 5 equal to 0, and x equal to negative 5. So these are the values that should not be in our denominator. I'm going to show it on number line for you. This is 0. Let's say this is negative 5 and this is 5. These two numbers are not part of my domain. So everything else is included in my domain. How do I show this in interval form? You're moving from left to the right, and we see there is an arrow here. So you start from negative infinity, and at negative 5, you have to stop. Because negative 5 itself is not part of the domain, so you put parentheses. And then union, after negative 5, again, you start until you go to 5. Again, this is not included, so you stop, union, and 5, and after that it's going to continue. So this is the domain of this function. Next question, we have a rational function again, but on the top we have a radical. We know that if you have a radical with index 2, this is square root, on the radical should be always greater than 0. So there are two basic things that we need to consider. On the radical, greater than or equal to 0, and under the fraction, the denominator should be not equal to 0. So we have two parts. T minus 6 greater than or equal to 0. That means t should be greater than or equal to 6. And on the other hand, 4t minus 28. This should be not equal to 0. So I'm going to make this equal to 0 to solve for t and see what is the value that makes the denominator equal to 0. So I exclude that. So 4t is equal to 28, and t equal to 28 divided by 4, which is 7. So let's show it on the number line, see what we have. The first part, all the t values which are greater than or equal to 6. So let's say this is 6. So everything greater than or equal will be this part. But on the other hand, t should be not equal to 7, basically, because this is the value that makes the denominator undefined. So I'm going to mark 7 here. Let's say 7 is here. There is an open circle here. This is what we don't need in our denominator. So I'm going to erase this part. So now I'm ready to write the domain of this function. Starting from left to the right, I start with 6, and it's a closed circle, so I put bracket. Then when I reach to 7, I have to stop and jump after that. So 7 to infinity, because after that it's going to continue. So this is the domain of this function. Question number 3, we are given f of x and g of x. We want to find f plus g of x. So this is basically just f of x plus g of x. We just add those two polynomials. It's 5x plus 2 plus 2x minus 3. Combine the like terms. 5x and 2x is 7x. 2 minus 3 is negative 1. What is the domain of this function? Domain of f plus g is basically domain of f intersection with domain of G. So you need to find domain of each of them and find what they have in common. Well, domain of F is just negative infinity to infinity because this is a simple linear function. So for F, I'm going to show a number line. It's everything, negative infinity to infinity. G also the same. This is also another linear function. So that's also negative infinity to infinity. And what do they have in common? Well, the whole domain is in common between both of them. So this will be just negative infinity to infinity, which I can show this one, any real number. Next one, find f minus g. Well, this one is again to subtract two functions, f of x minus g of x. 5x plus 2 minus 2x plus 2x minus 3. Okay, notice that I put a negative and then a parenthesis around the second function. That means this negative belongs to both of the terms over here. You have to distribute that. So this is going to be 5x plus 2 minus 2x plus 3. So negative times 2 is negative 2x, negative times negative 3 makes it positive. Now combine the like terms. 5 and negative 2 make it 3x. 3 and 2 makes 5. So 3x plus 5 is f minus x. What is the domain? Again, domain will be any real number because for this one also you need to find domain of f, intersection domain of g, which we already found. Okay, next part, you want to find f times g. To find f times g, simply you multiply the two functions. 5x plus 2 times 2x minus 3. So I'm going to start foiling, distributing. 5x times 2x is 10x squared. 5x times negative 3 is negative 15x. 2 times 2x is 4x. 2 times negative 3 is negative 6. Now combine these two like terms. This will be 10x squared minus 11x minus 6. So that's the function. Domain is again the same thing in a real number because that's also domain of f intersection with domain of g. Now next one, f divided by g. So you're going to divide the two functions. This is f of g, f of x over g of x. So that's 5x plus 2 over 2x minus 2. And I cannot simplify this, so this is my final answer for f over g. That's the answer. Now I want to find the domain of this function. So notice that this one is going to be a little bit different. To find domain of f divided by g, you need to know domain of f and domain of g, so intersection, plus you need to also add this. G of x should not be equal to 0. So we need to find what is the value that makes the denominator or g of x here 0 and exclude that from the domain. Okay, so far I know domain of f intersection with domain of g, like those separate functions, is just negative infinity to infinity, all real numbers. But what makes the denominator equal to 0? So you're going to set 2x minus 3 not equal to 0. That means 2x not equal to 3, and x should be not equal to 3 over 2. So this is the value should not be in my denominator. So if I show a number line, this is 3 over 2. So from negative to negative infinity to infinity, everything is covered except this one. So how do I write the domain of that? You can just write, I'm going to write that here, negative infinity to 3 over 2, and then 3 over 2 to infinity. Okay. Next, we want to find f plus g of 3. So for this one, you can do two different things. You can either find f of 3 and add by g of 3, or you can just use the equation that we had here. We found that here 3x plus 5. We can use that and find the answer. Well, in this case, it was f of 7x minus 1. I can use either of these two. I'm going to show both ways. So you can use either 7x minus 1. So you plug in x as 3. That's 7 times 3 minus 1. It's going to be 21 minus 1, 20. Or use this one. What is f of 3? It's 5 times 3 plus 2. And what is g of 3? That's 2 times 3 minus 3. Okay, this one, 15 plus 2 is 17. This one, 6 minus 3 is 3. And 17 plus 3 is 20. So you see both cases have the same answer. So you can use either of them. Okay, next one, finding f minus g of 2. So the function that I found was 3x minus 3x plus 5. This was f minus g. Now I just plug in 2 here. So that's going to be 3 times 2 plus 5. 6 plus 5, 11. So that's the answer. F times g, we found that the equation was 10x squared minus 11x minus 6. So we're going to plug in 4 into x. So this will be 10 times 4 squared minus 11 times 4 minus 6. And the answer will be 110. F divided by g. Well, the function was 5x. Write that again for you. 5x plus 2 over 2x minus 3. So just plug in 1 for x. So this will be 5 times 1 plus 2 and 2 times 1 minus 3. 7 over negative 1, which is equal to negative 1. Okay. Let's work on next question. We have this function x squared plus 6, and we want to find the difference quotient. Difference quotient has this formula. So we're going to plug in x plus h into the function and x into the function and find this difference. So first I'm going to find f of x plus h. What is that? Let me erase this part and clean. Okay, on my quotient, I'm going to write f of x plus h first, which is, instead of writing x squared plus 6, I write x plus h squared plus 6. So this is the first one. And now I'm going to write the second one, which was just simply x squared plus 6. Don't forget to put that in a parenthesis or a bracket like this, because you need to distribute the negative later. And this is x. This is 8. Okay, now let's just simplify, distribute, and then simplify. What is x plus h to the power of 2? Let me write that here for you. X plus h times x plus h. That's x plus h to the power of 2. Now, x times x times h times x, and h times h. And when I simplify these two combined together, it's going to be 2xh. So I can write that here. We have, this was x squared. We have x squared plus 2xh minus h squared. And I had a plus 6 here. So this is the first one. The second one, you're going to distribute the negative. Negative x squared minus 6. And h here. Now we start simplifying. X squared and x squared cancel. 6 and 6 cancel. And I'm left with 2xh over h. Now the h cancels here. Oh, and also I had a negative h squared. So I can, let me do it again for you. Minus h squared. So I can factor the h from the top. is going to be 2x minus h over h. These two h cancel, and it's equal to 2x minus h. So the answer is 2x minus h. Okay, let's work on the next one. Again, we want to find the difference quotient. So you're going to find f of x plus h. What is f of x plus h? This function, I'm going to write that here. It's supposed to be x squared minus 6 times x plus 5. I'm trying to write x plus h. But instead of x, I'm just writing x plus h. So this is the first one. The second one, I'm going to write that with a different color, is just f of x. So I write this inside the parentheses, x squared minus 6x plus 5. Don't forget this parenthesis because you need to distribute the negative later. Okay, and this divided by 8. We talked about x plus h, and we learned that x plus h squared is this times itself, and when you distribute, you're going to end up having x squared plus 2hx plus h squared. Now I distribute the negative 6x minus h, and I had a plus 5 here. Now distribute this negative x squared. Negative times negative makes it positive 6x, and this will be negative 5. Now let's get rid of the terms that are similar and opposite each other. So the ones that cancel each other is x squared, negative x squared, negative 6x and 6x, 5 and 5. Okay, let's see what we have here. And also this was negative 6x. I forgot to write that. Let me fix that for you. Okay, so this was negative 6x. Now let's see what do we have left here. We have 2hx minus 6h plus h squared divided by h. As you see, h is in common between all these terms. So I factor h out. So the first one will be just 2x, the second one will be negative 6, and the third one is just h divided by h. The h cancels, and the answer is 2x minus 6 plus h. Oh, sorry. So 2x minus 6 plus h is the answer. Okay, next question. We're given this function and we want to know what is the x value if f of x equal to 18. Okay, so we're going to use the function. I'm going to write x squared minus 2x plus 3. This is f of x and it's equal to 18. So we want to solve for x and know what is the value of x for this equation. The first thing that I'm going to do is move the 18 to the left side. So put everything together. 3 minus 18, and here is 0. So I have x squared minus 2x minus 15 equal to 0. Now I want to factor this. What are the two numbers that if you add them, you get negative 2? When you multiply, you get negative 15. Okay, those two numbers are negative 5 and 3. So I can factor as x minus 5 times x plus 3. Notice, because the a value here is 1, that's why I can just write x minus 5x plus 3. If this a value was not 1, then you had to turn this to 4 terms and then factor by grouping. Anyway, now I can set its factor equal to 0, x equal to 5, x plus 3 equal to 0, and x equal to negative 3. So these are the two values of x if f of x equal to 8. Okay, next one is asking us to find the value of a if we have this equation. This equation, f of 2 is equal to 1. Well, So this 2 is our x value, and this is f of x. So we're just going to plug them in here. Okay, so f of 2 is 1, and that's equal to 3 times x is 2. So instead of x squared, I write 2 to the x to the 3, I write 2 to the power of 3, plus a times x squared will be 2 to the power of 2, plus 2 times x, which is 2, minus 5. Okay, so let's simplify all these. This is 1 plus, this will be, equal to 24 plus 4a plus 4 minus 5. Now move all the numbers to the other side. So this will be 24 plus 4 minus, that's 23. So I have 1 plus 1 equal to 23 plus 4a, and I move 23 to the other side. So negative 23 is equal to 4a. Well, actually, negative 23 plus 1 is negative 22, and you divide by 4. So a will be negative 22 over 4. And you can simplify, divide by 2. This will be negative 11 over 2. So the answer is negative 11 over 2. Next question is asking us to find value of a if this point is on the graph. Okay, so we know that x is 1 and 5 will be f of x, or the y value. So let's just plug them here. F of x is 5, so I write 5 equal to a times x is 1. 1 squared plus 4. Now just solve this. 5 will be, this is just a plus 4, and you subtract 4, and a will be equal to 1. Okay, next question. The graph of f of x and g of x are given, and we want to find what is f plus g of 3. So you just need to find f of 3 and add g of 3. Find both of them and add them. So what is f of 3? Look at my graph. This is f. F of 3 is 4. So that's 4. And g of 3 is 0 plus 0. It's equal to 4. So this is 4. Next one, f of 5 plus g of 5. F of 5 is 2. G of 5 is negative 4. So this will be negative 2. F of 7 minus g of 7. What is f of 7? It's 0. What is g of 7? That is also 0. So the answer is 0. Now g minus 7, g of 7 minus f of 7. Just find them again. F of 7 is 0, g of 7 is also 0, so that's 0. F times g of 3, so that's f of 3 times g of 3. F of 3 is 4, g of 3 is 0, so 4 times 0 will be 4. I'm sorry, will be 0. F over g of 5. So this will be f of 5 divided by g of 5. Okay, f of 5 is 2. G of 5 is negative 4. So you simplify, it's going to be negative 1 over 2. Okay, next question. We want to find the intercept of this function. What are the intercepts where the graph is crossing x or y axis? So one of them is this one. At this point, it's crossing both x and y, so it's going to be 0 and 0. The other one is this point, which is, I guess it's at somewhere like maybe 2.5. So I'm going to write 2.5 and 0. What is the domain of the function? So you're moving from left to the right. The first point that you see here is negative 3. So negative 3. And it's part of the graph, so you put bracket, And as you continue moving forward at 3, the function is ending, so this is your domain. The range, you move from bottom to top. So this one, left to the right, range is bottom to the top. The first thing that I see is this y value, which is -1. So start from -1, and the last point is 2. And you put bracket for both of them. Where is the graph increasing? So let's look at the increasing part of the graph. As you see here, it's constant, then goes down, then constant, then goes up. So the increasing part is this one. You're just going to write x of a star, comma, x of end. This is what you need to write. X of a start is at 2, so you're going to write 2, and end is at 3, so 2, 2, 3. Decreasing part. Decreasing is this one, from this point to here. So x of a start is -1, x of end is 1. Where's the constant part of the graph? Well, one of them, we have two constant parts. One of them is here, which is from -3 to -1, and the other one is from 1 to 2. So I'm going to write -3 to -1, and the other one is 1 to 2. Now it's asking if the function is even or odd. Well, even functions are symmetry to the y-axis. Like, let me show you, draw you the graph of an even function. So let's say this one, which is graph of x squared. This is symmetry to the y-axis. That means left side and right side are a mirror of each other. And then, so this is even function. Odd function could be something like x to the power of 3, that the graph is symmetry to the origin. That means any point here has a mirror on the other side of the origin. So this is odd function. And as you see, we don't see any of these symmetries on our function, so it's none of them. Okay, next one is asking us to find the absolute maximum. There is no absolute maximum here because we have an arrow here that is going to infinity. So that means there is no absolute maximum. Is there any absolute minimum? Yes, that's this one. So 0 and 1. So I'm going to write f of 0 is equal to 1. Local maximum will be this one. This is the maximum of all the points around itself. So I can write 2, f of 2 is equal to 4. Notice that -1 and 2 is not a local maximum because the endpoints never count as a local maximum or even local minimum. Local minimum, yes, we have a local minimum here and another one here. So we have two of them. So it's going to be 0 and 1, 0 and 1, and the other one was 3 and 3. So f of 3 equal to 3. Okay, next question. So we want to find the domain and range of this function. I'm going to start with graphing the function for you. So we have two parts, x minus 1, that the equation will be -3x plus 5. So what x values do I choose here? I always start with this endpoint number, even if I don't have an equal sign here, 1, 0, and I'm going to try two other numbers which are less than 1. So find the y value of that. Plug in 1 here. This will be -3 plus 5 is 2. This will be 0 plus 5. This will be 3 plus 5, 8. And I'm going to graph the second one, find the points of the second one as well. X greater than or equal to 1, x, and the equation is 3x minus 1. So the values that I'm going to choose is 1. Always we choose this one first, and then 2 and 3 numbers which are greater than that. So plug them here. The first one will be 2. This one will be 5, and 3 will be 8. Okay, now I'm almost ready to graph my function. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Okay, when x is 1, y is 2. So that's here. When x is 0, y is 5. 1, 2, 3, 4, 5. When x is negative 1, y is 8. So 8 will be somewhere here. Okay, so I can connect these lines together. And notice x is less than 1, so I'm not going to draw anything of the right side of the graph. Here is where the graph is going to basically start, and I'm going to put open circle. And on the other side, it's going to continue. Next one, when x is 1, y is 2. So that's right here again. X is 2, y is 5. That's going to be here. X is 3, y is 8. Almost here. Now I'm going to connect them. So this is my second part of the graph. Notice that at 1 we have equal sign, so this will be closed circle. However, if you have an open and closed circle on top of each other, they can just change to be a solid line. And that's it. This is going to be my graph now. And now, what is the domain? As you move from left to the right on the graph, you see that every x value is covered. So this will be negative infinity to infinity. What is the intercept? We have only one intercept, that is here, and that's 0 and 5. So this is 0 and 5. That's the y-intercept. And now it's asking what is the range of the function. As you see, the range of the function is from bottom to top. It starts from this point, which is at y equal to negative 2, and goes to infinity. So your range will be negative 2 to infinity. I apologize, 2 to infinity. And I'm going to choose this one because it says there is no isolated value. Isolated value means these dot points that you see, the single dots. We don't have anything like that on our graph, so nothing. So I can just write 2 to infinity, and I'm going to put a bracket here. Okay, next question. Again, we have piecewise function, and we're going to start with graphing them. When x is less than 0, the equation is 4 plus 2x. What x values I'm going to put here? I start with 0, even if I don't have equal sign. Then negative 1, negative 2. The y values will be 4, 2, and 0. Next one. X and x squared. When x is greater than or equal to 0, you're going to choose 0, 1, and 2. This is 0, 1, and 4. Okay, so I can graph my function. Okay, let's start. When x is 0, y is 4. So 0 and 4. This is the first point. Negative 1 is 2, and negative 2 is 0. So my line is going to be this one, and I go only to the left side because it's x less than 0. We don't draw anything on the right side. And here I have an open circle because of this sign, which is just less than, not equal to. So this is the first one. Second one, when x is 0, y is 0, x is 1, y is 1, x is 2, y is 4. And I notice that this is x squared. That means I have a parabola. So I'm going to draw the line as a curve, not a straight line. So this will be my line, the curve, and then I can put a closed circle here. Okay, so what is the domain? As you move from left to the right, you see that although there is an open circle here, but this point is covered somewhere else. So I don't have to worry about that. I don't need to stop. So from negative infinity to infinity, everything is covered. Intercept of the function is only 0 and 0. And this is one of them, and the other one is this one, which is at -2 and 0. So we have two intercepts. They're both x-intercepts. This one is not counted as an intercept because we have open circle. So this is not an intercept. Okay, the graph of the function, we already graphed it. The range of the function, again, as you see, as I move from bottom to top, all the y values here are covered by this graph. So it's coming from -infinity. And then as I see, this part is covered by two different graphs, which is okay. And here, although I stop here and there is an open circle, but this point is covered somewhere else with another graph, and it's going to continue. So again, the range will be -infinity to infinity. And I'm going to choose this one that says there is no isolated value, -infinity to infinity. Okay, next one. We have the graph of piecewise function and we want to write the equation for that. So let's look at this one. You know that this is a linear function, so the equation should be y equal to mx plus b. What is m? That's the slope of the function. So that's rise over run. What is rise over run here? As you see, from 0 to 0, 0 and 0, we have moved to 1 and 1. So that means rise over run is 1 and 1, 1 over 1. And what is the b? That's the y-intercept, and that's at 0 and 0. So the equation is y equal to x. So this is for this function. The other one here, again, mx plus b. The slope is again 1 and 1 because we go 1 up and 1 right to move from one point to the other one. So this is 1 over 1. And what is the y-intercept? It's here at -2. Sorry, the y-intercept here is at 2, this point. Although it's an open circle, but it's okay if we just consider the equation of the whole line, the y-intercept here at 2. So plus 2. So y equal to x plus 2. Okay, so what is the domain for this function? This one on the left side starts from -1. Sorry, -2. The x value of this point is -2 and ends at this one, which is 0. So the first one, x plus 2 from -2 to 0. The second one, the equation is y equal to x. So you just write the x here, and x is greater than or equal to 0. So that's my function. Okay, next one, we want to write the equation of a function which the parent function is square root of x and it's reflected over x-axis. So if it's reflected, that means we put a negative behind the radical. It's moved 4 units up. So after the radical, you're going to write plus for 5 units right. So you write x minus 5. So that's the equation. Next one, again, we want to write the function, a square root function, which is transformed in this way. Vertical stretch by a factor of 3. So y equal to, you're going to write the 3 behind the radical, down 2 units. So you write -2 outside of the radical, right 4 units. So you write x minus 4. Question number 17. First, we want to know what are the transformations that happen to this function. As you see, x is subtracted by 1. That means this is moved right 1. And added by 4 outside of the function. So this is moved up 4. So we have cube function, which is moved right 1, up 4. Okay. Now we're going to graph the function. So first of all, let's find these points here. On the graph of x, y equal to x to the 3, if x is -1, y will be -1 to the power of 3, which is -1. 0 will be 0 to the power of 3, 0, 1 to the power of 3 is 1. So these are the 3 points on the parent function, x to the 3. Now, how do I find the corresponding points on the transformed function? Since we have moved the function right 1 and up 4, So right one means add x by 4. I'm sorry, by 1, because we have moved the right one by 1. And then up 4 means add y by 4. So we're using the same thing here. So here, negative 1 and 1 will be negative 1 plus 1 is 0. Negative 1, the y value plus 4 will be 3. Next one, 0 and 0. X added by 1 will be 1. Y added by 4 will be 4. X added by 1 is 2 here for this one. And y, which is 1 plus 4, will be 5. So these are the points of my transformed graph. Now I'm ready to graph those values. Okay, I have 0 and 3. This is one of them. Next one is 1 and 4. And then we have negative 1. And then we have 2 and 5. 2 and 5. So these are my points. Now I can graph my. Okay, so this is the graph of x to the power of 3. So I just follow the same pattern of x to the power of 3 that looks like this, and then just graph them based on. Okay, domain of the function will be negative infinity to infinity. Range will be also the same because for cubic function, there is no restriction here. Okay, next one, again, we want to know what are the transformations that happen here. So the first thing that is happening here is we have a vertical stretch by factor of 2. And we are moving the function right 2, right 3, and then up 2. So these are the transformations that are happening to the function. The reason I'm saying vertical stretch by 2 because this 2 is outside of the function and it's greater than 1, so it's vertical stretch. Now let's look at the points here. If I have graph of x, y equal to x squared, which is the parent quadratic function, if x is negative 1, y will be negative 1 squared, which is 1. X is 0, y will be 0. X is 1, y will be 1 squared, which is 1. Now, how do I find the transform point? So this is what you need to do. You need to add any x value by 3, and then you need to multiply any y value by 2 because of the vertical stretch, and then add 2 because of up to, because we are moving the function up. So let's try them here. Any x value should be added by 3. So negative 1 plus 3 will be 2. 0 plus 3 will be 3. And 1 plus 3 will be 4. So this is my x values. How about y values? Multiply 1 by 2, which is 2, and add by 2, that's 4. 0 times 2 is 0, plus 2 is 2. 1 times 2 is 2, plus 2 is 4. So these are the points. Now I can graph those points. Okay, so this is my graph. These three are the points that we had here, and we follow the general form of a quadratic function, which is a parabola. What is the domain of the function? It's negative infinity to infinity. But what is the range of this function? We see that from bottom to top, we start from the y value, which is 2. So the domain, the range will be 2 to infinity, and we put a bracket here. Now, let's look at this function. We have a square root function, which is transformed by vertical stretch by factor of 2, and it has been moved to right 1 and down 2 because of this. Okay, so how do I graph this function? Okay, let's first of all look at the parent function. Parent function of square root of x, this is parent function, has 0 and 0, 1 and 1, and 4 and 2. These are the first 3 points that I'm going to graph. Okay, this is the parent function. So the points were 0 and 0, 1 and 1, and 4 and 2. So how they are changed here? Any x value is added by 1. So I'm going to write that x value should be added by 1, and then y value should be multiplied by 2 and subtracted by 2, because we have down 2. Okay, so the points will be this. X0 plus 1 is 1. 1 plus 1 is 2. And 4 plus 1 is 5. How about the y value? 0 times 2 minus 2 is negative 2. 1 times 2 is 2 minus 2 is 0. 2 times 2 is 4 minus 2 is 2. So these are the points. Now I'm going to use this to graph my transformed function. Okay, so first point 1 and negative 2. So when x is 1, y is negative 2 here. When x is 2, y is 0. When x is 5, y is 2. And now I follow the same pattern and graph my function. And here I have a closed circle because it was closed here as well. So this is my graph. Now, what is the domain of the function? The domain starts from 1 to infinity, left to the right, and range from bottom to top is from negative 2 to infinity, and a bracket here. Okay, so next question, we want to look at this graph and find the graph of transform function. This one is f of x plus 2. That means it has been moved up 2. So which graph looks like this has been moved up to? And it looks like it's this one, because this point is at 2, and it has moved to the 2 points up here. So this should be up 2. This looks, it has moved to right, and this one moves up and left, so they are not the answer. This one, f of x plus 2, this is moved left 2, because x is added by 2. So this is inside the function, it has been moved left 2. So the one that I see here is none of them, because my PDF file did not graph the part D, which was part D. So it's just this function, which is moved 2 to the left. So if you see the graph that looks like this, kind of this form, that's going to be our graph. It should be moved left. This one is negative x. That means this is reflection over x-axis. So which one is a reflection of this function over x? It looks like it's this one. It's just reflected over x-axis. This one is moved left 1 and down 1. So again, I don't have that here in this shape. So if you see a graph that looks like this has been, these points moved left 1 and down 1, then you should choose that one. I don't have the graph here. Next one is 1/2 times x. This is vertical compression. So the graph which is shorter basically is going to be our graph. So it's going to be shorter and wider. And that's going to be this one, because the graph is half tall comparing to the original one. Over here, this graph is half tall and also 2 times wider. So this is vertical compression. And this one is negative f of negative x. This is reflection over y-axis. So as you see, this one seems to be a reflection of y-axis of this function. Okay, and my PDF file, this did not print the graph for this one, but anyway, f of 2x, this is horizontal compression of the function. That means horizontally is compressed. So the graph will be taller and more narrow, because the x is multiplied by 2. So this is going to be opposite compression by a factor of 1/2. So it's going to be 1/2 narrower. Okay, this was the first part of the review. I'm going to make the second part of the review for the other questions in a second video for you. I hope this was helpful for you. Thank you. Have a great day.